Hi, I'm Danielle Domo, and I'm about to present you my dissertation thesis, which is about antimicrobial resistance surveillance in pediatrics at the Bambino Jesus Pediatric Hospital of Rome. Antimicrobial resistance are said to be increasing at an alarming rate. It is due to the overuse and the misuse of antimicrobials mainly, and it is urgent to prevent the spread of these resistances, which have mainly increased during the years due to globalization, tradings of antibiotics, and traveling among people. In 2020, the World Health Organization documented that there were already about 7,100 deaths per year, and that in the near future there will be more than 1 million deaths per year if no action is taken. We can see from this table from Morrison and Zambo in 2021, an article documented in 2020, that from 2010 there weren't any more antibiotics introduced in the market. While on the other side, we can see that the antibiotic resistance identified to 2011 were already that many. Antimicrobial resistance is known to be either intrinsic, acquired intrinsically, or in an acquired way. The intrinsic way is a natural occurring way, independent of antibiotic and universally found within the genome of a group of bacteria. So it's transmitted to a family of bacteria, like as an example on the Klebsiella pneumonia resistant to ampicillin. Interesting resistance mechanisms include lack of outer membrane permeability to lack of target sites, passing by the presence of non-specific efflux pumps. The acquired mechanism, on the other way, is the most dangerous one for the clinical setting, as the bacteria acquires the capacity from another bacteria or from an environmental factor to become resistant to a specific antibiotic. It occurs in two ways: due to gene mutation or acquisition of a foreign DNA that encodes resistant gene. We have the vertical gene transmission and the horizontal gene transmission. And the horizontal gene transmission happen in three ways: the transduction, the transformation, and the conjugation. These are well described in most microbiology settings, so we will focus more on the conjugation way of transmission. The conjugation is the sharing of the plasmid. The plasmid is a ring, a DNA element that you can see on the picture in blue, that is transferred to another bacteria called here the recipient through the merging of through the linkage of the recipient to the donor by the pilus that you can see on the image. At the end, at the fourth point of the transmission, you can see that the old donor has still the phage and it has the pilus, but the new donor as well has both the F phage and the pilus, which means that the two of them now are capable of transmitting again the plasmid element to other bacteria. So far there are in total 4 general types of antimicrobial resistant mechanism, but over 10 specific types and subtypes of resistance mechanisms currently are in management in the laboratory. The antimicrobial susceptibility testing methods are varied, but there are documented two different type methods, that are the classical methods and the automated methods. The automated methods are the most commonly used nowadays in most laboratories in developing countries, like at the Bambino Gesù Pediatric Hospital. When the classical methods are usually used as well for verification. We have the diffusion method, the Agar diffusion assay, antimicrobial gradient method. But for the purpose of this study, we will focus on the MALDI-TOF, which is one of the automated methods that was recently found in the 1980s. On the MALDI-TOF mass spectrophotometry system, you can see that there are two routes of mounting the specimen on the target plate, which is a matrix plate to be mounted on the machine for identification of bacteria. The red line shows us the direct route of identification, while the blue line shows us the indirect route, which means that the specimen is not directly mounted on the target plate, but then it is first cultured on a microbiology media and then let for culture for growth under specific temperatures. From the growth of the bacteria on the media, it will then be mounted on top of the target matrix plate, whereby it will be the matrix will be added. The matrix is a reagent that will ionize the sample, which is the colony basically, or the direct specimen, and that target plate, which is an argent plate, will be introduced in the machine where the test will take place. The test takes place, as you can see, when the specimen is ionized. A laser light is flashed to the plate, and that laser light breaks the molecule into small pieces, and those molecules that have been ionized will fly in the tube of the MALDI-TOF, which is the separation tube, in the separation part of the detector, and the detector will measure the time at which those molecules do fly, and according to the mass of the specific molecule. For most bacteria at a time, the time and the mass of the specific molecules that are present that forms the bacteria have already been documented. So most of the multitop will have a graph like this one that tells you about that tells him which type of bacteria he has got to do with. So every time we insert a new plate for identification, it does detect the graph, it does detect the molecular pattern, and then it matches it with the molecular pattern that has been filed in the machine already. MALDI-TOF has been tested by several researchers in the past, and these are the results that some researchers have found about MALDI-TOF. That is a very accurate machine, and it works for gram-negative bacteria, for gram-positive, for anaerobics, for yeast and molds, for mycobacterium, for blood culture positive and negative. It is less often used for viruses for many reasons, but then it's not to be excluded. MALDI-TOF has got many advantages. We already named them. The most beautiful advantage of this machine is that it gives faster results. It analyzes a whole lot of samples at the same time. It is cost effective, but then we know that it needs a very expensive maintenance contract, and it did struggle a little bit to identify some very specific organisms, or to differ between the two. E. coli, for example, and Shigella's, Strep pneumo, and the Viridans streptococci. The current study will focus on making statistical analysis on microbiology data collected from November 2019 at the moment till December 2020 from specimens analyzed in the microbiology laboratory at the Bambino Jesus Children's Hospital under the MALDI-TOF and then under the antibiogram system that has been used in the setting. The aim of the study is to determine the impact of the insurgence of diseases caused by resistant bacteria on the therapy of immunologically depressed children in ongoing intensive care therapies. We will analyze the data through Excel and RStudio to see which ones have got antimicrobial resistance and which ones haven't got antimicrobial resistance among the immune depressed children. How long has been impacted the therapy with the insurgence of this antimicrobial resistance with the presence of the therapy that the kid was already going through. And then we will try to determine as well the impact of the antimicrobial resistance of the patient health status. How has that impacted the status of the baby? We will estimate. We hope that 10 to 30% of our result falls between the confidence interval and that the p-value falls between 0.01 to 0.01. All intensive care unit kids will be included, those from the oncology hematology department or from the chirurgy department or from the neochirurgy, and the non-intensive care units like pediatry, neurology, the donors, the ambulatory, the one coming from clinics, they will not be considered as immunology depressed kids because they are not identified as such by the hospital. So far, the 2020 annual surveillance report of cumulative antibiogram of the hospital has filed that the control procedure is going well. So we trust that the hospital is among the best hospital taking part in the control of antimicrobial resistances in Europe. The preliminary results have already so far gave us that among the immunodepressed kids, we have 29 that have got the antimicrobial resistance. So we hope we still have a lot of sample to analyze. So we hope to really fall underneath the prescription that we set it before. There are strong evidences of the impact of antimicrobial resistances and antimicrobial use on the therapy of immunodepressed children. Good clinical practice may help control nosocomial infections and good adherence to public health control. We have no doubt that about the fact that the samples result predicts the expected outcome of the current study. We really hope that the study will be as we predicted. This is a summary of confirmed emerging antimicrobial resistance events reported by countries in January 2019. They are coming up emerging antimicrobial resistances. So we understand from files from the GLASS and from the World Health Organization's reports on antimicrobial resistances that our study is important. We need to do this kind of surveillance as much as possible in either developing countries and non-developing countries to help to help educate the health caregivers about the importance of controlling the spread of antimicrobial resistances, because this chart, for example, shows us that most countries are affiliated for enroll for the antimicrobial resistant controls and stewardship, but then few of them, as this map shows, do actually file the report and send it back to the World Health Organization. And this is a problem because it is important to file the results and to collaborate with the global associations of surveillance of and stewardship of antimicrobial resistances. The problem in developing countries is that most of them, like in Italy, do report the results, but then in the report, the infection origin, the site where the specimen was taken from, is not filed, which is lacking information. Is not that good. Most of the bacteria that come from different sites would have somehow different biological patterns of action in the body. So it's important to document in the report the site of origin of the sample. The global state of antimicrobial resistance surveillance shows us that always from the World Health Organization in the GLASS report shows us that a bacteria like E. coli, for example, but most bacteria like E. coli identified from urine sample are already resistant to so many antibiotics, which is a problem. We have another example of Kleb pneumo. Resistance to so many antibiotics. Most of the antibiotics are from the same family, but then what we're trying to say here is that we do not have to get to this point where we have so many antibiotics that do not function anymore with just one bacteria. There is much to be done to understand the situation of antimicrobial resistance in pediatrics. Accurate reporting can help control trends of emerging and re-emerging resistances. We think that much is to be done at the current hospital to maximize the use of MALDI-TOF because we only use it for bacterial identification. But we recommend that where possible, the surveillance of the program should be emphasized on, and people should be educated on participating on this surveillance program. The surveillance program should be improved and provided in as much as possible countries. Antimicrobial susceptibility testings as well method should be the aim of focus of more of companies that would like to help in low developing countries, and we should build up easily understandable and applicable policies for the control of antimicrobial resistance. Thank you.